Hi guys, just wait a moment. Let me just check whether it is live or not. I hope we are live. Yep, we are live. Yes. So, hello everyone. Welcome back again to our channel Coders Arcade. This is Saurabh, and we are back with our Java DSA live sessions. Okay. In the last session, last week, we had talked about queues, and I had asked you one very important question. Okay, so again, let me welcome all of you to our Java DSA sessions. And obviously, we are at Coders Arcade, right? Where we try to make learning simple so that everyone can understand all the concepts and they can go ahead and crack interviews. Okay, so here this is Saurabh, and I am your trainer for today. And we have been continuing our data structure playlist where we have been learning a lot. We have learned all the searching and sorting algos. Then also we have learned about the linear data structures. We have learned about stacks, and we have learned about queues. And last Friday I asked you one question. If I show you here, you will understand this. Blue eyed boy says, good evening sir. Shreya, sir, please make video on collections in Java. Shreya, definitely will do that. Let me finish off with linear data structures, that is linked list. Will cover up in today or maybe tomorrow. 2-3 sessions will cover up linear data structures. Then we will go to collections. Okay, don't worry. I will not go anywhere. I will be here only and will be covering collections also. Okay, so that will be done. Don't worry about that. And guys, for today at least bear with my voice might be a little bit on the lower side because I'm not feeling well, but still the playlist should go on and we should be learning रुकना नहीं चाहिए, तो उसके लिए I am here live. Okay, so anything, any doubt, please let me know. I will be there to guide you. Okay, सर आपने गलत किया था उसका लॉजिक. Yes, very good, blue eyed boy. It should be like that. So let's go back there and try to understand that. If you see here, this was the code, right? We had created a class Q and everything was fine. But the point was, when we added 6, 7, 8, the max size was kept 5. So ultimately, they were not getting added. If I run this, try to understand this. See, 6, 7, 8 was not added. Absolutely fine because the max size was 5. But after that, if you see here, I had actually dequeued. I have removed one element from here, and then I had seen the size. If I go back again here, the queue elements from front to rear are 2, 3, 4, 5. This is absolutely fine. But still, when I called the size method, I did not get 4. I got 5. Whereas it should have been 4, right? So as blue eyed boy said, very good, this is not a good practice. So let's try to understand that, because the point is we have not done any modifications to this formula. This formula will work, but sometimes it doesn't work. So better what you do is, you can take, if the stack is empty, then obviously you will return 0, right? You can just return 0 like this. Otherwise, you can return, as you said here, I think, yeah, blue eyed boy says rear minus front plus 1. So rear minus front. For example, in this case the rear index will be what? 4. Yes, 4 minus 0 plus 1. So yes, front is at index number what? Let's see if it works now. Let's run this and check. See, this is what I asked, and I really love it when you guys actually go home and try to work it out and try to actually relate what was wrong in the question, and it really makes me very happy when you try to do it on your own. So this is the logic here. As you can see, it should be rear minus front plus 1, because otherwise the value will not get decremented. It will stay at that position only. And why does this happen? Because while we remove one element, the front index goes forward. It went to index number 1, right? So this is 5, or you can say 4. 4 minus 1, 4 minus 1 is 3, 3 plus 1 becomes 4. That is how the answer is acquired here. Okay, so this is about it, and with this we have understood about this thing, very important. Now guys, what we will do is, today we will be starting a very important data structure, which is linear data structure, and that is what? Linked list. We will be implementing a linked list from scratch, and at the same time, after finishing that, we will try to do some interview questions also. Maybe not today, at least tomorrow when you are finished with linked list basics, the implementation of the code, then we will go on and try to solve some questions, because without questions I don't think your learning is perfect. When you have used your logic to build something or to solve some questions, then only you can feel that okay, yes, this topic is over, let's go to the next topic. Okay, yeah, Shreya says thank you sir. So yes, definitely we will be learning about collections, Shreya, don't have to worry. And let me just check if there is any other message. Not yet. Okay, all good. So now let's go to the next important topic in our list, that is linked list. Okay, so today we'll be learning about linked lists. Lots of examples that you have in your real life. Your mobile browsers, your web browsers, you have the forward, you have the backward, and then you have the refresh button. And say for example, your Spotify playlist, you have the play button, you have the pause button, you have the forward and the backward navigations. These kind of navigations use the linked list. Okay, I am giving you some real time examples. Just 1 second guys. Okay. So as I said, these are real time examples where we use linked lists. So let's try to understand how it works and what are the categories. Okay, for example, there are 3 categories of linked lists. Okay, I'll just give you names, and obviously you will know them, because if you are here means you will be either studying engineering, or maybe your BSc IT, or maybe MCA, or maybe your MTech. So in all the cases you will have learned linked lists somewhere or the other. So basically they are of 3 types: singly, then you have doubly, then you have circular. Okay, so let's try to understand them one by one. So I will tell everything from scratch, you don't have to worry. Let's go here and try to understand that. See the logic, how it works. For a singly linked list, there is an entity called node. Okay, this is something called a node, and I am right now talking about a singly linked list. Okay, and each node of a singly linked list has 2 things. For a singly linked list, it will only have 2 things. Okay, it will have something like this: the data of the node and the address of the next node where it is connected. Think like a what to say, train. The first compartment is connected to the next compartment, and so on. It goes on like this. Okay, so this entity is called a node, where we have a data and we have the address of the next node. Okay, so now it will be connected to the other node, for example, and so on and so forth. It will also have the same thing. It will have the data and the address of the next node always. What happens here? I can only move forward, because this does not know where it came from. Got it? I only have forward access. Therefore, in a singly linked list, only forward traversal is allowed. Okay, forward traversal. Make sense? So this is how it works. So each node, the entity node has two parameters, the data and the address of the next node, okay, not previous node. That is a doubly linked list, that is totally different. For the time being, just don't think about that. Just think that each node of a singly linked list is connected to the next address like this. So for example, say suppose normally in colleges you will have learnt about what to say, linked list using integers, numbers. I will take strings. Say suppose I have Java here, Java, and then I am writing is, and then I will have one more node, for example, and I am writing like this. This is also the data and the address of the next node. So other than add, you can also write next. It is totally your choice. Let's write, okay, let's not confuse you. Let's write next only, so that you guys can remember it easily. Let's write down next and also next, here also next. Next means the address of the next node, okay, where we are going, so that I know where I am going. It is totally fixed, okay. So in that case, Java is the data, so I am taking a stringly linked list, okay, string data. You can take integer also, it's totally your choice. Now excuse me, Java is, say I am writing awesome, for example, something like that, okay. So this is a string, this is one more string, and this is one more string. Make sense? So what happens, this is always connected to the next one, this is always connected to the next one. So therefore backward traversal is not possible. I know that from this node I can only go forward to the next node, okay. And there are two more terms that you will hear a lot. The first node of a singly linked list is called the head, and the last node is called the tail. Somewhat similar to real time, the beginning is called the head and the end is called the tail, something like that. So if this is the tail will never point to any other data, it will point to what? Null. In case of C and C++, you will write null ptr, or you can also write capital null, okay. This is the syntax for C and C++, C or C++. In case of Java, you will simply write null, small letters null, okay. That is how it is, okay. And for example, if the address of this node is 1000, then this address is stored here. Got it? That is how the first node or the head can go to the next, okay. Similarly, if this is 2000, this address is stored here, okay. And because it is connected to null, this address here is null. As simple as that, okay. This is how a singly linked list operates and functions. Hope you are understanding this. Blue eyed boy says, I have a doubt. Yes, blue eyed boy, please tell me what is your doubt. I am listening, please tell me. I think I am waiting for you. You can tell me. Okay, the basic idea I hope you have understood. The head node is connected to the next, and so on and so forth, and the last node or the tail node is connected to the null pointer. So this is the address of the next node, this is the address of the next node, and similarly null is the address of the next node because it is connected to null. Simple as that. That is how it works, okay. And yes, so push operation में आपने लिखा था ARR of plus plus top, ठीक है, okay. That I will explain. Okay, definitely. Just I will do one thing for my reference. I will just, okay, I'll store it somewhere so that I can remember that. No problem. That is a different topic. It is about the queues. So we'll do that later. Okay. For the time being, I hope this much is clear. Now let's do one thing. Let's go back and try to understand some more things. Okay. The most important operations of singly linked list or any linked list are actually, let me write down, the insert operations, okay, and the delete operations. Okay. So, insert operations we have at head, some people might say front, at end some people might say tail, and after specific node. Okay. Similarly, delete the head node, delete the tail node, and delete target node. These are the most important operations of singly linked lists, okay, or doubly linked list or circular linked list. There may be some other modified operations, but most of the times you will be learning these. Insert at head, insert at tail, insert after specific. Why after? Normally it is asked like this because we don't know the previous access, we don't have previous access, it is only forward traversal, right? And delete the head node, delete the tail node, and delete a target node. Say suppose I am having 1, then 2, then 3, then I am having null. So you need to delete 2 for example. Okay, and also here please remember one thing very important, they will ask you the differences between an array and the linked list. For that you have to understand some conditions. Let's try to understand that, then we will go on and implement a singly linked list from scratch. Okay. Difference between arrays and linked lists based on certain operations. First operation is our insert operation, and second operation is our search operation. Okay, and I think I should be writing that this is not here, this should go at the bottom here. Okay, let it be here. Fine. Try to understand. Very easy, very important also. Insert operation. I have an array like this, and I have a linked list like this: 1, 2, and 3, and say null, null. Okay, now someone comes and says I have to insert 4 here at this juncture here. Remember insert. Okay, so what are the steps? Very simple. I delete this connection, I add this connection, I add this connection. Got it? How many steps? Deleting is one step, adding that connection is second step, adding one more connection is 3 steps. So it is always finite, it is countable. So the time complexity of insertion operation in a linked list is big O of 1. Constant, 3 steps always. Anywhere you want to insert, it will be always 3 steps. Remove the previous connection, add the other 2 connections. O of 1. Now let's talk about an array. 0, 1, 2, 3, 4 and 5. See, I have 2, 5, 6, 7, 8, 9. I want to insert 4 here after 2. Insert 4. Now to insert 4 here, I don't have gap. This is a what to say contiguous memory, right? These are addresses actually. So what happens, I have to shift the whole thing to the right hand side. Pura ka pura I have to shift it to this side. Okay. So what will happen is this will create a space like this, then only I can do it. See, I shifted all 5, 6, 7, 8, 9, 5, 6, 7, 8, 9 to the right side, then only I got a block space. The space was generated and 2 was here. Then here I can insert, say for example 4. Got it? That number that I am saying. So what is actually happening? All the n elements, whatever n elements are there, they had to be shifted to the right. So the time complexity of insertion in a singly linked list or a doubly linked list is always big O of n. Got it? That's why when you are using insert operations, please use a linked list. Don't use a array. It will save you lots of time. Got it? Hope it is clear. Now, yes, about the search operation, I'll explain it here only, okay, at this place, because rather than writing here, let's write it here. Try to understand. Search option. This is the array. Say it is 2, 8, 6, 9. This is 0, 1, 2, 3. Someone comes and says in an array, find the third element. What will you do? I simply have indexing. I'll just say ARR of third element, right? Index number 2. I got directly 6 is the answer. How much time? Big O of 1. Time complexity is very fast. At a single go I can find the number. But in case of a linked list, I have 1, I have 2, I have 3, and then I have null. Someone says give me the third element. I have to traverse first one, second one, third one, because I don't have direct access to the third one. I have to traverse. What happens here? The time complexity, big O of n. If I have n number of elements, all of them I have to traverse one by one. Got it? That's how you have to understand. Insert operations always take a linked list, not an array. Look at the time complexity. Search operations always take an array. Don't take a linked list because you have to traverse. Look at the time complexities. Hope you have understood this. Okay. Now I hope all the idea about an array and a linked list is clear. Now we can directly go and start implementing a linked list. Okay. So hope you have understood this. Anybody has any doubts, let me know, or else we can directly go and start writing the code. Okay, give me 1 second. I'll just drink one glass of water. Okay. So I hope this is clear. These two are very important. So please try to understand the insert and the search operations. Okay. Now let's go ahead and start implementing a singly linked list of what? We will take strings. Go back, and what we will do, we will just create a new package. In linear data structures we had stacks and queues, and then right click, new package. This time let's write down not stacks and queues, this time it is linked lists. Okay, here let's create a new package, singly. I'll just write singly linked list. Fine, and right click and create a new class. What is each entity of a linked list called? It is called a node, right? Let's take right node only, so that it becomes easy for you to understand. Okay, and let's talk about the structure also so that we can understand. So in the linked list, guys, you might have learned linked list while you were studying in third sem, and you have learned while DSA, right? But you might have mostly done it in C language or C++. Maybe C++, most of you might not be knowing, doesn't matter. So here you might have done using what? Struct. In C you might have done using struct, but now we will be using classes and using the features of object oriented programming. So a singly linked list, you can see each node was having the data and the pointer to the next node, right? So I will take a class, and this entity is called what? It is called a node. So I will take a class of node, and in that, what is the first parameter? It is our int data. Okay, and then I need the pointer to the next node, that means the reference to the next node, that is also a node only, right? Node of next. Got it? Because this is also a node, the next one will also be a node, it will not be some other type, it will be a type of node only. That's why we are creating a reference variable of node and pointing to the next one. Got it? This is how it works. Make sense? And initially the next will not be connected to anyone, we can write it equal to null, equal to null. Make sense? So let's try to write it down. I have not got any comments, so I will think that everything is fine. So excuse me, let's write down the code now. Try to understand. I am taking string, okay? So string data, the data of the node, and then the pointer to the next node, node of next. Make sense? This is how my structure of the node will look like. Every node will have a string here in case of the data and the pointer to the next node. Okay, class node. Here I have written in data for numbers. You can take string. Okay. Then when we have learned corrections, then we will be doing a generic one also. That is also very important. Okay. Now let's create the constructor, and I will take the data from the user, and what I will do, I will just say this dot data, this dot data is equal to data. Okay. And as I said, initially the node will not be connected to any further nodes. So I will say next is equal to null. For safety, you can also write this dot next equal to null. Okay, this dot next equal to null, and you can write something like this. If you want a comment, you can write we don't have access to the next node initially. Okay, initially we don't know whether it is connected to a new node or not. Okay, make sense? And one more thing, guys, we have not used any encapsulation, right? So let's try to do that so that it becomes more efficient, the code becomes more efficient. So rather than writing like this, we can write the data something like this. Try to understand. So this is fine. Now what I will do, see what I am doing now, try to understand. I am taking a class called LinkedList, LL. Okay, this is my class, and what I will do is I will wrap the whole code around this. See what I am doing. I am copying this whole thing, copying and pasting it inside this. Sorry, let me just cut this. Rather than copying, let me cut this from here. Okay, Control X and say Control V. Okay, confusing? It will not be confusing. Once I write down the whole code, it will be easy for you. So my main thing is the node, that is actually each node of the linked list. So what I have done, I have wrapped it inside the linked list class. Okay, now what I will do is, what is the first node of the linked list? It is the head node. Okay, sorry sir, cannot attend the class now because it is raining heavily in our area. No problem, blue eyed boy, you can do one thing. you can have the recording after the session. I'll post the recording in the group only, okay, in the playlist only. You can take that and you can learn from there. Any doubts, please ping your comments in the comment section, okay. So as I said, the starting node is called the head. I'm creating the head pointer, okay, got it. And then I will take one more variable to control the size, the number of nodes, okay. So I'm taking private int size. And initially, if the linked list is empty, what will be the size? So I'll take the constructor and then I'll simply write the sizes is equal to 0. Got it? So have you understood what I have done? I have wrapped the whole node class inside the linked list class, and then I have taken the head pointer, and then I have taken the initial size of the linked list to be 0, and also I have taken this variable size to control the size of the added elements. Once I add one element to the linked list, the size will increment, okay. So hope you have understood this. Let me check if there are any comments. Okay, not yet, all good. So hope you have understood this, right, till here. Now let's go to the next part of the code. As you see here, whenever the constructor is called and we are creating a new node, see, the constructor of the node is actually to create a new node. What happens? Think practically. Once you have created, see, I will just give you an example like this. This was nothing, okay. Let's take the diagram. The board is blank. Now I added a node by calling the constructor. I had the data and the next pointer. The size increased, right? The size, the number of nodes increased to 1. So shouldn't we do size plus plus so that we can keep a track of the size, right? So let's write down that. Go back and let's write down here. After this, we'll write down size plus plus. Makes sense? Once we create a new node, we will increment the size of the linked list. Make sense? Okay, this is the basic idea of this thing, and you can write down a comment here saying increment the number of nodes. Initially it was 0 here, size equal to 0. When I get a new node, automatically the size will increment it. So I am just doing it automatically here, so that each time I create a node, automatically the size increases. Okay. Any doubts, anyone, you can tell me in the comment section. Right now I don't think there are any more doubts, so all good, fine. So now let's do one thing, let's create all the other methods. So this is the node constructor done here, it is finished here. Now let's create the methods. So first method is, I'll write public void, we need to print the elements. I'll say print list elements, you can write, or you can write print list, your choice, totally your choice, whatever you want to write. Okay, and try to understand this, important. Let's write down like this, 1, then 2, then 3, then null, for example. So we want to print something like this, 1, 2, then 3, then null, correct. So I have to traverse from the head only, because this is the only way I can access my linked list. So I will take something like this, I will take a current pointer pointing to the head, and I will just say like this, while current is not is equal to null, because if I reach null I should stop. Got it? Once I reach null I should stop. So while current is not equal to null, I will print the data, right? That is our target. So system.out.println current dot data or value, whatever you have written, you print that, okay, and then you can concatenate one space here. After that, current equal to current dot next, because I need to move to the next. So current will come here, then current will come here, and once current comes here, it will stop. Make sense? That is how we print the elements in the list. So let's do one thing. Let's write down the same thing. I said I will take a current node curr is equal to pointing to the head, okay, and I'll say while my current is not is equal to null pointer, print the data first, okay, because that is our target. I am trying to print the elements. So I am removing the ln and I am saying current dot data, okay, plus let's give a space. Rather than giving a space, let's make it more interesting. Let's write like this way: one arrow, 2 arrow, 3, then arrow, then null, something like this, okay. So let's try to write it. Data plus, I am giving an arrow like this, and okay, so we will print this. Then I need to move to the next pointer. Current is equal to current dot next, got it. This will create like this, and after printing the whole thing, let's go to the next line and print a null, okay, got it. This should work, and after the arrow will automatically come, then it should print null. Now let's validate this, if this is working or not, okay. So what I'll do, I'll go to the main and create a list, okay. So I'll say linked list LL is equal to new linked list, okay, and excuse me, I'm doing it manually, okay. LL dot head is equal to node, say 1, for example. Will this work? Let's see what happens here. Let's make it static for the time being. Just wait, okay. I'm just writing something like this, okay. The data is string, right? So let's write A, then head ll dot head dot next is equal to new node B. I'm just trying to print, okay. So ll dot print list. Let's see if it prints actually. Yeah, very good. Non-static cannot be. So this way you will not understand. So rather than confusing you guys, let's do one more thing. Let's not write it like this. We will do a very different way so that you can understand the concept, okay. So let it be for the timing like this, and let's remove this static class. Otherwise the whole concept of a singly linked list will be gone out of your mind. Just a moment guys, 1 second. Anybody has written any comments? I don't think so. Right now everything is fine. Okay. Nobody has said anything. So what we do, let's do one thing. Let's add the methods one by one, then we will try to insert the elements like this. So this print list function should work. So what we will do, we will add elements, then we will try to understand one by one all of them. So very simple. I'll say public void add first. You can also write insert at head, insert at front, that is also fine, okay. And what are you adding? I am adding string data, okay. So just remember one thing, very important. Let's just clear off all these things and try to understand one thing. I want to insert something into a linked list. What is that something? That something is a node, okay. So just remember, for all the insert operations, you have to create a new node. Okay, create a new node, that is mandatory, you have to do it. Okay, so you will always write this thing, node of new node is equal to new node with the value, whatever the value is given. So in this case, what did you write? You wrote string data, nothing you have to write. Okay, that is mandatory. So let's write down that line. Create a new node. So node of new node is equal to new node, and let's pass the data here in the constructor. Done. And try to understand, very simple and very easy to understand, because you are learning Java, you are not learning C or C++. Why is it easy? Imagine something like this. I have an empty list, empty, nothing is there. I created the new node, this is my new node with the data, say A, B, C, whatever it is, really doesn't matter. Okay, now if my head is pointing to null for the time being, think like that, because it is empty. Okay, now what I will do, I will say this is the new node, so new node dot next will be the head, makes sense. New node dot next will be connected to the head, and because this became the new node, the head should be pointing here. So new node dot next will be the head, and the new node will become the head node, because from here only it will start, correct? The new linked list will start from here only. So head is equal to new node. These are only the two things that you have to do. For multiple conditions also, if you see here, say suppose I had 1, then 2, and then I had 3, and then I had null. If you are inserting 0 here, or say x, y, z for strings, then what will you do? This was the head, so new node, this is the new node dot next will become the head, and the head will be updated to the new node. As simple as that. Those two lines only you have to write. Okay, so let's do one thing. Sahaj Dubey says fine. So yep, let's write down the code again. Hope you have understood this. New node dot next will be connected to the head wherever it is. If it is null also doesn't matter, and then the head will be updated to the new node. That's all. This will add elements at the beginning of the linked list. And very beautiful concept that people can ask you in the interview. In C or C++, you have to use free to delete the memory, or you have to use the delete keyword in C++. In Java, not required. The JVM will delete the data. Whatever is garbage will be deleted. So you don't have to worry about that. Once you are creating a memory using new keyword, it will be automatically deleted. Fine. So you don't have to worry about that. Please remember that. That's very important. So let's try to see whether it is working or not. Okay, because without working code we will not be understanding anything. So let's do one thing. Now let's take the example, and 1 second guys, I told you right, I'm not feeling well, so still like we have to continue the playlist. And also see, like the point is very simple, like if you are interested, I will go on for the whole day, it doesn't matter to me. But if I don't get that motivation, obviously I will also become down, and will like gradually lose what to say, the interest on the topic also, and that will not be a good thing. So I want to help you guys, so at least those who are new to the channel, please help us by subscribing to the channel. That's a very important thing that you can do. Okay, इससे ज़्यादा motivation नहीं चाहिए मुझे. You subscribe, you watch the videos, you learn something. At the end, it's a win-win situation for you guys also, for me also. Okay. So what do I do? Let's take the variable linked list. List is equal to new linked list. Okay. Now list dot add first. See, add first, and let's add something here. I will say coders arcade. Okay, this is the string. After that, I'll say list dot add first, channel, and list dot add first. I'm writing coders arcade channel our. So what should be the output? It should be our channel coders arcade. Got it? Let's try to do this thing. List dot print list. Let's see if it works or not. See, our channel coders arcade, and if you have come here, please subscribe to our channel. Okay, that's very important. If you want me to write that, you can do that. I will write that, no problem. But hope you have understood. Adding at the beginning only. So coders arcade at last, then channel, then R. Okay, our channel coders arcade. Got it? Hopefully it is clear. Any doubts? Please ping me in the comment section. Yes sir, I attended class learning with concept today. Thank you sir. Very good Sahaj. So keep learning and keep understanding, keep solving questions. That will be the most important thing for you guys as long as you don't get a job. After you get a job, then this DSA will not be coming. Then what will come is skills. Start developing things, start learning about new skills. That will be very important for you guys. Okay, that you have to do. Okay, so I hope add first point is clear. Now let's write down the next one, add last or insert at tail. Okay, that we have to write now. Any doubts? I'm waiting for you guys. You have to tell me if you have any doubts. Otherwise, let's go and write public void add last, or you can say insert at tail. This L should be capital. Otherwise, see, even my IntelliJ is warning me. This is not a good practice of writing. This should be camel case. Correct? See, when I wrote the L small letter, it is giving me a warning. This is not a good practice. Green color is not an error, it is a warning. So better be sure about what you are writing. It is very good. So obviously, what are you adding? We are adding data only. So as I said, first option is very important. Create a new node. Anywhere you are adding, you have to create the node. So I am copying this part. Done. Added a new node. Any comments, anything? Let's check. All good right now? No problem. Okay, let's continue. Fine, guys. After that, what? Add at the last. Think and tell me what should be the conditions. First condition is empty. Very important. Let's write down the conditions one by one. Add at tail end last, same thing. Empty. If you are adding to an empty list, what will happen? Obviously that node that you added will become the head and the tail, and it will be pointed to null. How do you check? When the head is null, then the linked list is empty, right? So let's write down that thing. And always write comments so that you can remember. Empty list. Okay, and let's write down like this. If our head is equal to null pointer, that means the list is empty. In that case, what will happen? I said the head will become the new node, the new node will become the head, and you will just return. You will not do anything else. You can just write head is equal to new node, and don't do anything, just return from the method. Make sense? This is as simple as that. Otherwise, interesting but easy only. Try to understand. Second case, list with multiple nodes. I have 1, I have 2, I have 3, Guys, I am not writing strings because I have to write names, rather I am writing numbers only. This is for your understanding, okay? Okay, just uh, don't try to confuse yourselves. Even if it is number, even if it's string, character, whatever, the data is data only, right? And then this is null. And here I have created the new node 5. This is the new node that I need to insert after 4. After 4, multiple nodes. So this is head. What I will do, I will take a current variable and see the logic what I am writing. While I don't want to insert at null, I want to insert at 4. So 4 dot next is null, mind you. 4 is not null, 4 dot next is null. I cannot insert after null, I have to insert after 4. Okay. So see the condition. While my current dot next is not is equal to null, this should be the condition. Okay. Keep going. Current is equal to current dot next. Okay. This should be your while loop condition. Let's see how it works. 1 second. See, current is here right now. Current dot next is not null. Current goes here. Fine. Current is not null. Current dot next is not null. So current goes here. Got it? This is how the loop is working. After that, current dot next is not null. So current goes here. Now see the magic. What is current dot next? It is null, so it will stop here. Did we find the last node? Exactly. Now my current is pointing at the last node. Make sense? And what will you do now? My current is pointing at the last node and its next is null, but its next should not be null, its next should be the new node that we created. Okay. So current dot next will be equal to new node. That's all. After the loop is over, they will do this. Okay. And one more point, the new node should point to null, right? Do you have to write this question mark, big question mark? We have to point the new node to null because this becomes the tail, right? The tail points to null. Do you need to do that? We don't need to do that. Why? Very simple. Let's go to the code. While we are creating the constructor of the node class, see what we have done. Node of next is by default null. So the new node that we created is automatically pointing to null. We don't have to point that again to null pointer. So this is not required. This is already done. Make sense? Hope this is clear and easy only, guys, not so difficult. Okay. So multiple nodes, you have to find the last node and after the last node insert the new node and then don't need to point it to null because you have handled that in the constructor. If you haven't done that, then you have to do it manually again. Okay. So till now, no doubt. Very good, Sahaj. Keep it up and try to understand the concepts. Let's go back and let's write down the code now. Till here is fine. Okay, it was here, right? Add last for multiple nodes. What is the comment? I'll write find the last node and insert the new node after that. Okay, find the last node and insert the new node after that. Fine. So node of current is equal to head, pointing from the head only because that is the only way of access. So I'll say while current dot next is not is equal to null, because I cannot insert after null. I have to insert before the null. That means after the last node. Okay. So current will be equal to current dot next. Make sense? And you can write after the execution of this loop, the current will be at the end. Okay. So insert the new node after the current. So I'll just say current dot next will be equal to new node. That's all. And this does not need to be connected to null pointer that I have already told you, correct? Or also guys, to make it simple, we are trying to find the last node, right? So you can refactor that to write last only. Okay, let me right click and refactor and rename that all code occurrences. Okay, so current, I'll just replace that to last. So because we are trying to find the last node, okay, so last equal to head, then last dot next not equal to null. This should be fine. Okay, now our channel code is arcade, and then now let's add some data here. I'll say list dot add last code is arcade. I'll say has list dot add last. I'll say 50k plus. I'll say list dot add last subscribers. So it will be our channel Codus Arcade has 50k plus subscribers. Let's see if it is working, and let's write the plus here only. Run this and check. Let's see if it is working or not. Wow, awesome, it's working. Our channel Codus Arcade has 50k plus subscribers. Hope you have understood this. Any doubts, please, I'm there, ping me in the comment section. Got it? So here we have got the output. Now we have seen insert at head and insert at end. Okay. Now guys, you guys can try to do the insert after specific operation. Not so difficult. The specific target will be given, and you can try to insert after that one. Okay. And one second. So I hope till now there is no doubt. So this is how you create a singly linked list, and this is how the operations work. There are two more operations left, but I want to show you one thing very important. Please remember, we will never be using this implementation in the interviews. This is just to understand how a singly linked list works. Okay, in the interviews I will show you here linked list, singly linked list, right? Let's write down here only. Right click, I'll just give you a new Java class, say linked list example. This is the collections framework java.util, and I think Shreya was asking me, right, to teach collections. So just see this, try to remember. Okay, main, there is an interface called list java.util. Okay, list of, as I already told you, you cannot take primitive data type, it will not be allowed here. You can see it is showing a warning, and I can write capital list is equal to new. List is an interface, it is being implemented by two classes. There are lots of them, but mostly we use array list and linked list. Okay, see here, new linked list. This is the linked list that you need in the interviews. Fine. And then see, earlier it would ask you about this, but now you can see this is highlighted in dark color, this is light color, gray color. That means in the latest versions of Java, this is not mandatory. If you write it also, it will not have any problem, but normally Java says, the compiler says, you don't have to write it, we will manage, we will try to handle that. Make sense? This is how it works. Now here I can just use list.add, okay, say integer, right, 1. See, this is not my linked list, this is from the java.util list. My linked list is here. My linked list that I created had these methods, add first, add last. Okay, this is from the collections, and let me just copy this one and paste it here. Paste, and say 1 13, say 21 and 15. Got it? If you want to print it, you can print the list directly. See, 1, 13, 21, 15. Okay, makes sense. If you want to use a for each loop, that can also be done. You can say, one second, you can just take something like this. For the data type is capital I integer. You can write int also, int x inside our list, s out. You can say x and remove the ln and give a plus and space, and after you have printed all of them, just give a space. And if you want an arrow, you can give an arrow also, like this. This is what I need to modify, okay, because normally the linked list will not print like this, and here I will say null. So it should be 1, 13, 21, 15 and null. Check. This is how it is working. Make sense? So you will be using this one in the interviews, not the one that we created. Provided they tell you that you have to implement your own linked list, then you have to write this one. Make sense? That is how you have to work on this. I hope you understood this. Great. Similarly, you have one more. See, this is a interface. See, public interface list. Okay, and here I am using a new linked list. Similarly, you have one more. I will just copy the whole content from here, or let's do one thing. Let's take one more file, okay? Let's not confuse ourselves and yourselves also. New Java class. This time I will say array list example. What I am trying to show you is real time abstraction, how Java handles abstraction. Okay, main method, and this time I will take list only, list of integer only, or say string. This time doesn't matter, string list is equal to new. See, that interface is implemented by so many: array list, linked list, you have abstract list, stack, you have vector. Okay, all these things are there. Got it? So I can use array list also. This array list in the collection has a built-in array. The other one, the linked list, has a built-in linked list inside that. Okay, this one is an array inside that. Fine. Now I can write like this, list dot. This one I can copy from here. These things are same. Or what have I taken? I have taken string, right? So list dot add. This time I am saying Java. List dot add. This time I am saying Python, and say list dot add. This time I am saying SQL. Sorry. Okay, and s out the list. Let's print. It should be Java, Python, SQL. Otherwise, you will not see any changes. But in the inner implementation, one has an array, one has a linked list. That you have to remember. Okay. So this is how it works. Hope you are understanding this. Got it? So depending on your requirement, you will use any one of them. And guys, one last thing I want to tell you before before winding up today's session, because I have not completed this one, right? We have only seen the add last and add first. We have not seen the remove operations or the delete operations. That we will be doing tomorrow. Okay, don't worry, I am not going anywhere. I will teach you all the concepts one by one. Fine. Hope you have understood till here. अगर समझ में आ रहा है, at least write down in the comments कि understood. Okay, it makes me happy, and like otherwise it feels like I am talking to myself. Whenever someone gives a comment, it is really helpful for me to understand that okay, the guys are following my teaching and they are actually trying to understand the things. Okay, as I said, this is fine, this is like this, and also you can use a for each loop for this one also. So here let me just copy that line from here. This line I will print, copy, and what you will do here, I will say paste. This is not integer, this should be string. Let's change it, and then it should be Java, Python, SQL, then null. Simple as that. But remember, while we were studying Java, I am talking about 2006, 7, 8, 9, 10, at that time, we were making lots of mistakes. Guys, EC department, उतना coding नहीं आता था पहले. So what you did, I will just show you a wrong example. Okay, I'm writing wrong example only. Wrong example. So see how we were writing this. This is not recommended, but still can be done. Okay, 1 second. Actually, I'm having a runny nose. What to say? So main, and here let's write down array list. This see array list directly I can write array list. No need to take list also. And I will not write any data. I will not mention new data. I will say list is equal to new array list. Got it? See, the compiler is not giving any errors, even warnings. Now, if you see, I can say list.add. It says object now, the base class of all classes, the parent class of all classes. Okay, I can say Saurabh. Okay, list dot add. I can give my surname and say suppose I'll say list dot add. This time I can say the year 2025 and let it be not string, let it be integer only. It really doesn't matter. It does not bother. List dot add. Say I'm adding boolean true. See, it accepts. But this is not recommended because now it can have any kind of data, but this was written earlier. Nowadays you have to fix it to write the data type. Now string will not be accepted, even boolean will not be accepted, but earlier it was possible. I showed you, right? If you remove this, it is possible, and then if you want to print this, and I can remove that value also, this one. Okay, and let's say s out list. Let's see what we are getting. We should be getting my name, then my surname, and then 2025 and true. It really doesn't matter, but still this is not a good way of writing. This is how I was writing when I was writing Java for the first time, because honestly speaking, in my engineering I never learned Java. We did not even know that it was a language at that time. Gradually when we joined the industry, our managers, they were shouting at us, and gradually we learned from them only, and we are thankful to those people. Actually, they had helped us a lot, because being in AC department, we never learn all these concepts in the colleges. Okay, so that's why, just to make you people understand, we are bringing up all these concepts so that आपको easy रहे and आप अच्छा से एक जगह placement ले पाओ. इसमें आपका ही फायदा है. It is all winning for you guys only. What we get some subscribers, some views, but actually honestly speaking, this is what I like, teaching people, and I'm following my passion. I hope you follow your passion and get a good job. That is what I want. Okay, does singly linked list have two pointer like head and tail, or only head? Initially it will have the single pointer only, because there is only one traversal from the head to the tail. Okay, xyz. In case of doubly linked list, we will have two pointers. In case of singly linked list, there is only forward traversal possible. Okay, no backward traversal. That's why in general we will have only one pointer only. Fine, guys. With this, I have showed you the collections example of the linked list also, and the array list also, and I have showed you real time exception. See, this is the interface which can be implemented by either array list, or it can be implemented by the linked list. Got it? And I have shown you one wrong example also, where you are not writing any data type and still it works, but it is not recommended. So tomorrow what we are going to do, we are going to finish this off and write the add first, remove first and remove last methods, and then we will go to other linked list options. Okay, and we will try to solve some questions also. Guys, it will take a lot of time, so we will be here at least around 1 more month. Gradually we will be completing all the concepts, because 1 hour every day will still take a lot of time to finish all of this. And I hope you are liking the content. Please, if you are liking, please mention that in the comment section. Thank you for watching, and what else to say? This word, I just want to say this word. Subscribe to our channel Coders Arcade. Okay, till tomorrow, this is Saurabh signing off. Bye bye and happy learning. Thank you guys.